So we start with the money and coin problems. So basically, this word problems in algebra will help us determine the total value of a set of coins or bills, or the other way around. You figure out how many pieces of which would be needed to come up with a certain amount. Usually, these problems are solved by systems of equations. So having normally two equations, two unknowns, but it can be more. Some by logical reasoning, by just using the um, by breaking down the value of a bill into coins and whatnot, or just simply unit conversion, depending on the amounts or other currencies if necessary. So let's take a look at the different money that you have, or the different coins and bills. So on your upper left, you have the one for UK. So you have the 1, 2, 5, 10, 20, and 50 pences, and then you have the 1 and 2 pound coins, and then we have the 5, 10, 20, and 50 pound bills. On your upper right, you have the US dollar bills. So 1, 2, 5, 10, 50, and $100 bills. Two usually is rare in circulation. Then the coins. This is one interesting part because they have different names for each. You have 1 cent is 1 penny. 5 cents is 5 cents is a nickel. 10 cents is called a dime. 25-cent coin is called a quarter. Then you have the 50-cent coin is half a dollar, and $1 coin, which is rare. These two last two are rare. And then definitely we have our own. In the Philippines, we have our new polymer banknotes, the 1,500, 150. I think we also have 200. And then we have the new generation currencies, 20, 10, 5, 1 peso, and then the centavos, 25, 5, and 1. So we'll be using a combination of this, or some of this, in answering money and coin problems. For our first problem, we have, or the example reads, you have two times as many dimes as nickels, and the total amount of money is $3. How many dimes and nickels do you have? So it is mentioned here that you have two times as many dimes as nickels. So that first part of the sentence translates, you have two times as many dimes as nickels. So that's dime, then twice your nickel. That's how we translate it. Okay. So right after defining, we let D as dimes, N as nickels, and then the relationship based on the first part of the sentence. The second sentence tells us the total amount of money is $3. So we have to multiply the number of coin with their corresponding amount. A dime is zero point 0.1, and then a nickel is 0.05. As you remember earlier um, from the previous illustration. Okay, so the nickel is zero point 0.5. 0.05, okay? And then it should be a total of $3. So we will represent this total amount in value with one variable only. Since we have the relationship at first that uh, twice as many dimes as nickels, we can write dime in terms of nickel. So you'll have 2n is equal to 0.1 plus 0.05n is equal to 3. Then you can simplify, you get 0.2n plus 0.05n is equal to 3. Combine like terms, 0.25n is equal to 3. Divide both sides by 0.25. So we have the number of nickels as 3 divided by 0.25, or 1/4, that is equal to 12. Your number of dimes is twice as the number of nickels, so that's 12 times 2, 24. So that will be your answer. You can check your answer by um, by getting the value of 12 nickels. So that's 0.05. So that's $0.6. Then 24 nickel, 24 dime is 0.1. So that's 2.4. When you add, that's a total of $3. That is correct. It confirms the constraints that you have in the problem. So example number 2 reads, suppose you bought 20 stamps consisting of 42-cent stamps and 24-cent stamps. The stamps cost $6.24. How many of each stamp did you purchase? So you had 42-cent stamps and 24-cent stamps. So it was a total of $6.24, and that is for 20 stamps. So we can let X as the number of 42-cent stamps, and then for the 24-cent stamps, instead of using Y, we can use 20 minus X, because you know the total, you have set 1 to X. So just since there are only two unknowns, just set 20 minus X, so we can go straight and solve for the value of X later on. So we can we can multiply 0.42 by X, and then 0.24 by 20 minus X. But don't be confused. Do not multiply 6.24 by 20, because 624 is not the price per stamp. It's the price of the total price of the 20 stamps. So it should be just $6.24, and that's it. Distribute the second term, so you get 0.42 plus 0.24 times 20 is 4.8 minus 0.24x is equal to 6.24. Subtract 0.48 on both sides. This will cancel out. Combine like terms, 0.42 minus 0.24. So that is 0.18. And then 6.24 minus 4.8, that is a total of 1.44. So divide both sides by 0.18. Okay? So you divide 144 by 0.18, you will get X is equal to 8. So therefore, you have 8 42-cent stamps, and the other one is 20 minus X. So that's 20 minus 8. So that is 12 for the 24. So, and 12 24-cent stamps purchased. Okay? Okay, let's start with the third example. Juanita paid for an item at the store and received $7 in change. She received 3 more dimes than she did nickels, and 3 more quarters than she did dimes. How many nickels, dimes, and quarters did she receive? So first, we let our variables, or define our variables first. We let n as our nickels, the number of nickels, and then b as the number of dimes, and then q as the number of quarters. So let's translate, and the relationships mentioned in the problem. We received $7 in change. Okay, so that's defined. The total change is 7. She received 3 more dimes than she did nickels. Okay, So to write that down, we can put in dimes, and then it says here three more dimes than she did nickels. So dimes is more than nickels, so nickels plus three. Same as with three more quarters than dimes. So quarters is D plus three. So these are our constraints. So take note that nickels are 5 cents, dimes are 10 cents, and then quarters are 25 cents. So if the total change is $7, how are we going to identify how many nickels, dimes, and quarters we set up the equation with the number of nickels n times 0.05 plus the dimes 0.1 and then the quarters 0.25 is equal to $7. But let's apply these relationships that we translated earlier. So our dimes is the number of dimes is n plus 3, so we can write that down. N is equal to 0.05 plus D is n plus 3, 0.1. How about the quarters? The quarters is D plus 3 times 0.25 is equal to 7. Okay? So we can rewrite the number of dimes into number of nickels so that we can have everything in nickel. So n is 0.05 plus n plus 3 is 0.1 plus the number of dimes is n plus 3, and then that is plus 3 outside from the original d plus 3. 0.25 is equal to 7. Now time to simplify. 0.05n plus 0.1n, we distribute zero point 0.1n, and then 3 times zero point 0.1 is zero point 0.3. Then we simplify this becomes n plus 6, and then we distribute 0.25 plus 0.25n plus 6 times 0.25 is 1.5 is equal to 7. Now combine like terms. So 0.05 plus zero point 0.1 is 0.15 plus 0.25 is 0.4n. Combine the constants, zero point 0.3 and 1.5, 1.8 is equal to 7. Subtract 1.8. You get 0.4n is equal to 5.2. Divide both sides by 0.4. So then we have n is equal to, so we have 5.2. Get n as 13. So the number of nickels is 13. We can use this in getting the number of dimes and quarters. Dimes is nickel plus 3, so it's 16. Quarters is dimes plus 3. 16 plus 3 is 19. So therefore, n is 13, D is 16, Q is dimes is 16, nickels is 13, quarters are 19. Okay? To check, just use this. You multiply it with 0.05, multiply it by 0.1, 0.25. So 13 times 0.05 is 0.25. $65. 16 times point 1 is 1.6. 0.25 times 19 is 4.75. So carry 1, 6, so 6, 12, 13, 20, 4, 5, 6, 7, 8, 4, 5, 6, 7. So we have a total of $7. Correct.